Let me introduce first myself. I'm Jair. Actually, the full name is José Jair Cardoso de Santana. But let's keep short, Jair. I'm a cloud security lead at Northwave Security, a security company in the Netherlands. And I'm also assistant professor at University of Twente. And you understand why I emphasize that. So I need to talk first about the problem of static threshold. Yeah, so let me give one example and I need your help, okay? So how much milk should I give to my daughter? Yeah, so I have a 1.5 years old daughter. She usually drinks, or we usually give to her 180 ml 3 times a day, 30 days. So per month we spend like we buy 17 liters of milk. And but then I noticed that sometimes she drinks everything and seems that are still thirsty. And sometimes she doesn't finish her bottle, obviously. And my wife used to say, well, better to put more milk than let her thirsty. Do you agree? Well, to me, it's not like that. I'm a data-driven guy, so I just ask her to give 200 mLs of milk. And then we count how much milk she drinks every day during the month of August. On average, she drank 172 ml per time. The minimum that she drank was 97, and the maximum was 200. Wait, we gave 200, she drank 200. Mm, that mean I could say something, nothing. That she just drink this on average. The 97, if I look to the graph, looks a pretty clear abnormal point. Yeah, and if it's 200, well, possibly she was thirsty. Then my question comes to you: how much more should I put on her bottle? Yeah, and then I said, first I need to explain something. That is what I explain to my students. That is the quantiles, percentiles, quartiles, median. So I'll bring you back to the school, okay? So here's the graph. And here are all the points, okay? So all the amount of milk that she drink, I just sort all the values, okay? Now, if I divide this in the middle, let me ask you which element, so which number is at the middle of the second list. And then you look to the list and say, looks like that is the 180. This guy is also called as 0.75 quantile, 75% percentile, or third quartile. But the value is 180. So if you look to the second or to the first part, and I ask you what is the element at the middle, you would say 156. And indeed, and this is called 0.25 quantile, 25 percentile, or first quartile. And then if I ask you which element is at the middle of this list of values, you'd say, Jair, there is not one single element there, but it's somewhere between the 176 and the 177. So why not to have this as the median? And this middle element is called median. Okay. So far, so good, I hope. So there is another concept that is really important for me to explain the rest, that is called interquartile range. That is basically the difference between Q3 and Q1, okay? It means basically what is the difference or which range of values are between this quartile and the top one. And then came this guy called John Tukey, not Turkey. And then he said, well, let's define a range to see how much this value would variate, okay? And then he said, well, if I would like to analyze the lowest point, I will take the Q1, and then I'll take the interquartile range, multiply by 1.5, and subtract this to the Q1. And he also proposed a definition of the higher value. That is, take Q3, take this interquartile range, this difference, and then multiply by 1.5. Okay? This was called honest significance difference, or Tukey's test, to define this up and down value. And then came this visualization. Who of you knows what is this visualization? Yes, it's a box plot. What you may not know is that the third quartile this value, the second quartile is the middle, the first quartile is this, the difference in the box is interquartile range, this is the lowest value, and this is the upper value. This is the moment that usually my student says, this is what the box plot means. Yes, and these values below are actually the abnormal points, okay? And I put something at the corner. This is not a normal distribution. For this reason, the values may be different. So if you remember, I asked and measured everything in August, and then I saw that I gave 200 mLs, but she reached the 200 mL. So thirsty, possibly. But after I did this Tukey test, I just took that value, the upper value, and then I asked my wife, please, let's give only 236. And then this is the graph of September. The max, so the maximum that my daughter drank in all this month was 217. Question, is she thirsty? Was she? No. Is it clear so far? So it means that instead of that 17 liters, it's better to buy 20 liters and guarantee that she will not be thirsty. And I could do this further calculation of the Tukey test per month, or I could do per day, or I could do per feeding, compare it to some past data. Is that clear? I hope so. Now applying to attacks. So if you just now take this graph, I remove, and I tell you that this graph had a peak right now. And I say that this graph represents the number of sign-ins of a user per day. And then you look to the graph, look to the peak and say, well, if this is the amount of sign-ins per day, what we have here is a huge peak of sign-ins. Well, I know this guy. This may be a brute force because this abnormal point there is clearly a brute force. Or I just need to further investigate. If I tell you that instead of this graph being a sign-in frequency, is a network traffic, from one IP sending traffic outside the company, and you see this peak, you say, this could be some type of exfiltration. And if I tell you that this graph is the DNS traffic, is the DNS request towards one domain name, you could say, well, this could be a command control communication. Did you get the point here? Is that you just need to use the Tukey test to compare that point to previous points, or to a previous number of points. Is that clear? I hope so. Now I need to introduce Sentinel. Who of you have no clue what is Sentinel? Maybe Mehmet has no clue. Sentinel is the SIEM, the Security Information and Event Management from Microsoft. Cloudborn offers UEBA, that is the behavior analytics and automatic response with SOAR. This is how it looks like. And Sentinel is for free. You just need to pay for the data that you need to ingest there. Okay, joke. So why I like Sentinel, first of all, is that you can integrate all the Microsoft stuffs. Duh. Well, if it's Microsoft Think, it's supposed to integrate to Microsoft Think. So, but I don't want to go there. It goes beyond. Yeah. I discovered work with Sentinel and my team of engineers that we can actually onboard any type of data from any type of security or non-security box. Okay. So let's say now that I can put inside Sentinel the identity management with the sign-ins logs, remember? Or the firewall logs, or the DNS server. So what I like the most about Sentinel is the flexibility. Because I play with a lot of SIEMs and we cannot write everything. There are predefined templates that, well, no. So I'm a data-driven person, so I want to use the data as I want and not as someone says for me to do. So this is where we can use the language defined by Microsoft, that is the KQL. And then when I started learning Sentinel and teaching to my team, I saw in the documentation that there was a function that implements exactly the Tukey's test. Nice. So remember these attacks? This is what the KQL looks more or less like. So this is in production KQL. So basically, I receive firewall log data using syslog. I make a series, okay? And then I just get that series and use the function to calculate what is the test of Tukey. And then I can see which values are higher than 1.5, okay? That 1.5 times the EQR. So basically here, I just use one internal IP address communicating to an external IP address with some abnormal amount of bytes sent in relation to the past. But I need to tell you what are the problems. How should you fine tune? Yeah. And how can you bring this live? Because I usually recommend for you first, before bringing it live, to test over the data. If you do tests with the data that you have, you will notice that these type of graphs will appear. So something that imagine that is outgoing data from one single IP to external IP addresses, okay? And then this IP address was almost no activity. And suddenly there is a peak, yeah? When I ask the analysts in the SOC if they should trigger one alarm, they say, of course, yeah, I see clearly in the graph, there is a clear peak. But then to consider this exfiltration, I need to know how many IPs these internal IP are communicating. If it's one, two, many. If there are many, I don't know if I would consider exfiltration. So then the other question is that if I run this over and over my past time, I don't know, yesterday, the day before, or 1 hour before, and so on and so far, do I notice this behavior again? And in one of the cases, one of the customers, we noticed that over time, some IPs start having this peak, yeah? And then I asked them, well, I sent a list of IPs and said, well, these IPs have abnormal behavior, and we noticed at this time, this time, and this time. And then they said, Jair, these list of IPs are behind NAT. So every time with the DHCP, someone receives a new IP, and then a new IP start exchanging data. Okay. Another customer, we see this behavior and there were some peaks. And then we asked, well, we did the test, sent to the customer, and he said, Jay, this specific IP is over and over every Monday doing some backups. Okay. And if this would be a DNS analysis, or the DNS queries to a specific domain, well, this is normal. It's like I tell you now, I tell in the chat what is my web page, and everyone would access that URL it means that the number of DNS queries generated within the company would be big. The question is this the normal or the abnormal behavior? Well, in this case, it may be normal and not a command control communication. So all these nuances you need to fine tune and fine tune with the customer. So before you bring live, test using as much data as you can. I tell my engineers to run 10,000 times the same algorithm. Just create a loop, go back in time, and leave the algorithm running for the entire night. Give me the data and let's contact the customer to clarify, to fine-tune your algorithm, to add which IP should be removed or which IP should be we cannot use blacklist, whitelist anymore, but okay. But yeah, remove or include, yeah, to be more whatever. And then after you create this list, you can bring your algorithm live. Looking to the feature and checking my time here, as I'm almost there. Basically, what I'm doing with the academia, with my students, is taking the entire list of MITRE, and then we are going one by one there and try to create a signature-based rule using KQL. And then in a second stage, we do the same thing using statistical methods, like the Tukey's test. But we also use some machine learning algorithms. And then the KQL, you cannot write a machine learning algorithms, but Sentinel allow us to use Jupyter Notebook. My life is saved. Now we can bring all our crazy machine learning algorithms to use the data within Sentinel. Now, guys, let me go. My little one wants the 217 of milk or less. Thank you very much.